What leads to the ideal gas law? It's really just a combination of all the laws we've put in place so far. Boyle's law, Charles' law, Avogadro's law. You put all those together and you will ultimately end up with the ideal gas law. So let's start with Boyle's law. Boyle's law is pressure times volume is a constant. And we've got that here now with pressure times volume is a constant. Now we're going to bring in Charles' law, where volume over temperature is a constant. So we simply add a T to this problem in the denominator. Now we've got what is classically known as the combined gas law. Pressure times volume over temperature is a constant. We now add in Avogadro's law, which is simply putting an N for the number of moles in the denominator. And now we've got pressure times volume over temperature times moles. All of that equals a constant. But this time the constant is rather special. This constant has a name. We're going to change it from K to an R. And the R is the universal gas constant, which has a specific value. If you choose to use, which we mostly do, liters and atmospheres and Kelvin temperature and moles, then the value you get for R is 0.08206 liter atmospheres per mole Kelvin. And that's what you use in a lot of your ideal gas law problems. There are other versions of R, and it's important to keep that in mind. So use the version of R with the type of problem you've been given, or if you're happy with this version of R, make sure you always convert everything into liters, atmosphere, Kelvin, and moles. That's the ideal gas law, and it works over and over in chemistry so many times.